Welcome all. Myself Shamla Devi, working as an assistant professor in the Department of Electronics and Communication Engineering at K.S.Rangasamy College of Technology. Today I am going to take about the concept on Superheterdyne Receiver in analog communication systems. A superheterodyne receiver is a type of radio receiver which converts the incoming radio frequency signal into a fixed intermediate frequency for easier processing. So the basic principle behind this receiver is frequency translation, where the received RF signal is mixed with a locally generated frequency to produce a constant intermediate frequency. So since this intermediate frequency remains fixed with respect to that of tuned station, which it becomes easier to design high gain and highly selective amplifiers. So this is the main reason why the super heterodyne receiver is preferred over other types of receivers. So we will see one by one blocks of super heterodyne receiver where RF amplifier and tuning circuit, mixer circuit with the local oscillator, IF amplifier and filter, demodulator side, and then at last audio amplifier. So we will see one by one how each blocks works for super heterodyne receiver. So first one is RF amplifier and tuning circuit. So the first stage of the super heterodyne receiver is here along with the tuning circuit. So the antenna receives very weak radio signals from different transmitting stations. So the RF amplifier strengthens the desired signal without significantly increasing noise. So the tuning circuit, usually an LC circuit, selects the required carrier frequency and rejects unwanted nearby signals. So this stage also helps in reducing image frequency interference before the signal is applied to the next level, which is the mixer. So the output of this stage is an amplified and frequency selected RF signal. So the next one is local oscillator stage. The local oscillator generates a frequency known as the local oscillator frequency. So this frequency is always offset from the incoming RF signal by a fixed amount equal to the intermediate frequency. When the receiver is tuned to different stations, the local oscillator frequency automatically changes to maintain a constant intermediate frequency. In AM receivers, the commonly used intermediate frequency is of 455 kHz. So the stability of the local oscillator is very important for proper receiver operation. So the next one is an important mixer circuit. So the mixer is a non-linear device which combines the amplified RF signal with the local oscillator signal. So due to its non-linear nature, the mixer produces new frequency components which is equal to the sum and the difference of the RF and local oscillator frequencies. So from these components which we have seen, the difference frequency is selected as the intermediate frequency here. So this frequency conversion process is the main part. We can also say it as the heart of the super heterodyne receiver and is mainly responsible for translating different RF signals into a fixed intermediate frequency. So the next one is IF amplifier and IF filter. So the IF amplifier is the most important stage of the super heterodyne receiver. So since the intermediate frequency is fixed, the IF amplifier and IF filter can be designed to provide very high gain and sharp selectivity. The IF filter removes adjacent channel interference while the IF amplifier boosts the signal strength for detection. Most of the receiver gains and selectivity are mainly achieved in this stage, which greatly improves overall receiver performance. So here is the IF amplifier and IF filter stage. So the next one is usually the demodulator side. So the demodulator stage extracts the original information signal from the modulated IF carrier. So in AM receivers, an envelope detector is most commonly used, whereas in FM receivers, frequency discriminators or phase locked loops are usually used. So this stage improves the carrier component and recovers the baseband signal, which is usually an audio signal which contains speech or music. An audio frequency amplifier. So the recovered audio signal from the demodulator is of very weak and cannot be directly drive a loudspeaker. Therefore, the audio frequency amplifier is used to increase the power level of the signal without changing its shape or frequency content. So this amplification ensures that the signal is strong enough to be heard clearly without any noises. Next one is the speaker. The speaker is the final stage of the receiver. It converts the amplified electrical audio signal into sound waves. So as a result, the original information transmitted by the broadcasting station is again reproduced in an audible form for the listener. So on the whole, when we compare the superheterodyne receiver with the other types of receivers, such as when we take tuned radio frequency receiver and the regenerative receiver, the superheterodyne receiver clearly offers superior performance. In a tuned radio frequency receiver, all amplification is done at the receiver frequency stage itself. So this makes it difficult to achieve high and uniform gain over a wide range of frequencies. And the selectivity of the receiver is also poor. As the operating frequency increases, the stability of the tuned radio frequency receiver decreases, which limits its practical use. So this is why these receivers are eliminated with the superheterodyne receiver. The superheterodyne receiver converts all incoming radio frequency signals into a fixed intermediate frequency signal, as I told before. Because of this fixed IF, the amplifier and filter stages can be designed for maximum gain and sharp selectivity. So this makes much better sensitivity and selectivity when compared to tuned radio frequency receivers. So the super heterodyne receiver also provides consistent performance of the tuned station frequency. When we take, that is when we compare to another type of receiver is a regenerative receiver, which uses positive feedback to increase gain and selectivity. The super heterodyne receiver is far more stable and reliable, because regenerative receivers are mostly prone to oscillations and distortion due to feedback, but the super heterodyne receiver avoids these problems by using controlled frequency conversion and a fixed IF amplification, which we discussed before. So overall, although the super heterodyne receiver is slightly even more complex and expensive when compared to regenerative receivers and tuned radio frequency receivers and other types of receivers, its advantages in terms of high sensitivity, excellent selectivity, and then its better noise performance and its a stable operation makes it the most widely used receiver architecture in modern communication systems. So this is why we mostly prefer super heterodyne receivers, because of its advantages of high selectivity and high sensitivity when compared to other types of receivers. So try to answer these questions uh, by listening to the content of super heterodyne receiver, which I explained here. Thank you all.